Hello everyone, welcome to uLearn Education Online channel. In the previous video, we have seen how the TCP IP protocol model will be there and what is the structure of TCP IP model and what are the functionalities of different layers that are present in TCP IP model. Furthermore, we have seen what is meant by protocol data unit and what is the notation that is used by each layer in PDU. Now we are going to see the concept that is TCP header. As we know that in the transport layer we are having two protocols. One is TCP and second one is UDP. Now let us see how the TCP header diagram will be present. Now what do you mean by a header? It means whenever you send the data to the TCP adds header along with the data. So here the TCP header provides a various functionalities for the sender to send the data properly to the receiver. Now we are going to see the TCP header model. So this is the TCP header model and it consists of various row functionalities. Here this TCP header size should be in between 20 byte to 60 byte. As we know that the value of byte in terms of bits is 8 bits. So 1 byte is equal to 8 bit. So I can say 20 byte is 20 into 8 which is equal to 160 bits. So the data should be more than 160 bits and less than 480 bits. Okay, now here the first field in the header is the source port and destination port, and here both the source port and destination port is having a size of 16 bit, and here this source port and destination port will perform end-to-end delivery. So as the size of source port and destination port is 16 bit, so how many combinations will be there? It is 2 power 16, so which is nothing but 0 to 65535, which means this 0 to 65535 we can call it as a port numbers. Okay, so in this range from 0 to 1023 up to 1024, these port numbers are used as a standard port numbers. For example, if I consider the standard web browser we are using, that is HTTP, for that the port number should be 80. Okay, so the remaining ports, that is from 1024 to 65535, these remaining ports are used in order to send the data or receive the data. So this is the functionality of source port and the destination port. Now next row is the sequence number. So as we know that in the TCP every byte is counted, since the TCP is a byte streaming protocol. So the collection of bytes we can call it as a segments. Now let us consider a segment, and I am assuming that the segment size is of 50 bytes. Okay, so here the segment size is 50 bytes, which means the starting number of the segment is 1000 and the ending number is 1050. Okay, so finally the size of the segment is 50 bytes. So here this number indicates the sequence number. So which sequence has to send the data to the receiver, that is indicated by the sequence number. In example, I have considered the continuous numbers, but whereas in TCP it simply generates the random sequence number. Okay, so this is what the sequence number will do. Now let us see what the acknowledgement number refers. So here this acknowledgement number refers when the receiver receives the data, then it sends an acknowledgement to the sender. For example, let us consider the same case as we taken in the sequence number, that is the segment size is of 50 bytes. So here the sequence number starting is 1000 and the ending is 1050. So let us consider that this is the data I want to send. Okay, so I am considering this data as Y. So I am considering this data as Y. So when the receiver receives this data, the receiver should send an acknowledgement to the sender as Y plus 1. So this is the receiver has to send the acknowledgement number. Okay, it means the data up to 1050 is accepted or received, and now send the data of 1051. Okay, so I can say that here let us consider the y value as the last data that is to be transmitted, that is 1050. Now what the receiver has to send? It has to send the acknowledgement as 1051, that is I want the data with the sequence number 1051, it indicates. So finally I can say that the acknowledgement number is next expected byte number. Okay, now let us see the next line, that is header path or header length. Here it is a 4-bit number. So the size of a header we are considering as a scale of 4 bytes. Why we have to consider the scale of 4 bytes is, as we know that the TCP header size should be in between 20 byte to 60 byte. Okay, since it is a 4-bit, but for byte I need 8 bits. So this address will not fit. So I have to consider the scale of 4 bytes. It means 4 into 4-bit number. Okay, now let us see what are the valid binary digits that are used in header length and what are the invalid binary digits that are not used. For suppose, or for example, if I consider the binary 4-bit digit is 0011, so which is a decimal 3. Now what is the size of the header length? Then it is 4 byte into 3, which is equal to 12 bytes. But we know that the TCP header size should be at 20 byte. That is, the starting header size of TCP is 20 byte, but here it is coming 12 byte, which means it is an invalid 4-bit number. Now let us consider the other number, that is 0101. Now what is the decimal number of 0101? It is 5. Now what is the size of the header length? Then it is 5 into 4 byte, which is equal to 20 byte. Since the TCP header size is 20 byte, this 0101 number will be valid, which means the valid 4-bit number will start from 0101 binary digit as the header size is 20 byte. In other words, I can say that 00002 0100, these are invalid bit numbers that should not be used, and from 0101 to 1111 those bits can be used as a header length. Now let us see next one, that is a reserved. So here this reserved portion is of size 6 bit. So these 6 bits are there for future use. Okay, now here we are having some 1 2 3 4 5 6 flags. Okay, now let us see what is the indication of each flag. Here URG means urgent. If some data is urgent to send, then URG should be set to 1. Okay, and ACK, which means acknowledgement. So whenever you are sending acknowledgement notification, then the acknowledgement should be set to 1. Why this should be used? Since in the acknowledgement number you are sending the next byte number. That's why here whenever the acknowledgement number is sended by the receiver to the sender, then this ACK should be set to 1. Okay, now what is the next flag? That is PSH. It is nothing but a push flag. In many applications, whenever the single byte is sending continuously by the sender, then the receiver stores the data in its buffer and waits until its buffer is filled. After that only the receiver sends the data to the application layer. But few applications require fast sending of data to the application layer. In that case, what the receiver has to do? Whenever the receiver receives the data at the time, without waiting, it has to send the data to the application layer. To indicate this, we have to set the flag PSH to 1. Okay, RST means reset and SYN means sync flag. This sync flag is used for synchronization. So whenever a first byte is sending a sync flag to indicate the connection to the server or the receiver. Now see the next flag, that is FIN, which means a terminate or a finish flag. Whenever the last byte is sending by the receiver, this fin flag is used to indicate the termination of the connection to the receiver. So these are the purposes of flag that are used in TCP header. Now let us see the next one, that is the window size. As the size of a window should be 16 bit, means the range is 0 to 65535. It is used to tell the size of window to both sender and receiver. For example, some X want to send the data to Y. Then it has to represent, or it has to indicate its window size to the receiver. Okay, similarly, when the receiver wants to send the data to the sender, then it has to indicate its window size. Okay, and the window size of both sender and receiver should be same. Since the TCP follows the full duplex system, the sender and receiver might send the data simultaneously at instant of time. Okay, now let us see, next one is the checksum. Here this checksum is used for error control. And the next one is an urgent pointer. It simply indicates the position of range of sending urgent data. Okay, and the last one is options and padding. Here the extra data is sending through options and padding, and these options and padding mainly indicates the maximum segment size value, that is MSS value. This MSS value will be helpful whenever the receiver receives the data from the sender. So this is all about the TCP header. If you are having any doubts, please present those doubts in the comment section. And thank you so much for watching our video. Keep supporting. Please subscribe to our channel.